Hello, Dr. Anbu. My name is Loendro Litama, and my student ID is 0383661. Today, I will explain a simple Java program which is called Carbon Footprint App. This app helps users estimate their carbon footprint based on electricity, fuel, and meat usage, and then compare it with the data international or global data. The main class of this program is called Carbon Footprint App. This is where the program starts running inside the main method, and it uses several other classes such as country data loader, country emission, and emission calculator. So that's why the command of this code is import because we need their class. Next, first of all, the app will try to load carbon emission data for each country using this code. List country emissions equals country data loaders dot load from resource this code. Then if it's fail, the comment will appear no data load. And if it's success, it will get the default data. Okay, next. The app will ask the user to enter the monthly electricity in in kWh kilowatt hours, monthly full consumption in liters, and monthly meat consumption in kilograms. So if we run the code, click run. Okay. For example, we use data 555, enter. For the monthly fuel consumption, 66, and the meat consumption, 777. Okay. The computer will process the data, and so your estimate annual carbon footprint is 271.76 in metric tons. So this data is about the Malaysian nationals average, the country's Malaysia. The CO2s of Malaysia is 277.53 metric tons, and the GHG is 306 and 0.70 in metric tons. And Malaysia's continent is in Asia, of course. The highest CO2 emitting country is China, which about the CO2 is about 12,670 metric tons, and the GHGs of China is one 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 million 240,000 metric tons. And also, the continent of China is in Asia, and the lowest country that emitting the CO2 is Angola, which about 0.02 metric tons, and the GHG is 0.00. And the continent of Anguilla is in North America. And if the process finish, and then it will be appear the thank you. But okay, next I will explain the country data loader. Okay, first of all, I will start by looking at the overall structure of the class. This code is in the data package, and it imports several Java class such as country emission, buffer reader, input stream, and list. So that's why the command is import because we need their class again. Okay, the class name is country data loader. It has two main parts. First, a public method which is called load from resource, and the second one is first emission value. For for the load from resource, The function is to read the data from a file, and the function of the first emission value is to help convert emission values such as 2.5 thousands or 1.3 millions into actual number. Okay, now let's focus on the main method, the load from resource. Okay, first, there's a code which is called input stream. Input stream is equals country data loader dot class dot get resource as stream emission txt. This line opens the file name emission txt, which should be located in the project's resource folder. This file is like expected to contain emission data in tabs separated format. Next, we have the code buffer reader equals new buffer readers new input stream reader is. Okay, in this code, after getting the file stream, we use a buffer reader, this one, to read the file line by line, or we can read the file one by one. Next, we have the code reader dot readline brackets skip header line. Okay, it means that the line skips the first line of the file, which is usually the header row country country emissions or continent. And next we have the codes while line equals reader dot readline and nose. So the program then read each line of the file until there is no more data. Then we have the next code, which is called string parts line dot split. So it means that the code for the each line is split into parts based on the type character. Okay, next. Then we go to the if part. Okay, for the if part, there's a there is a for if like string country, double CO2, double GHG, and string continent. If the line has at least four values, the code reads the country name, the CO2 emission, the GHG emission, and of course the continent. So that's why we make it four rows. First rows, second rows, third rows, and this is the fourth rows because we need the four values, and this is the code that will release the country name, the CO2 emission, the GHG, and the continent, as I already said before. Next, it used the helper method parse emission value. So this is the parse emission value. I'll explain it right now. To make sure the emission values are properly converted into number. So this is the function of the parse emission value. If value is empty, return 0. Uh, this method handles values like 2.500 and 1,000,000. It checks the stuff. So this is the command. And if the values end with k, if the values end with k, it multiplies the number by 1,000. Then the second, if it ends with m, this one, it multiplies the number by 1,000. This is 1,000, 1 million, sorry. and this is 1000 for K. And the last, if the value is just a regular number, this one, it converts it directly. And if the number format is invalid or empty, it says return zero. Yeah. So overall, the country data loader class helps lead emission data from a file, then convert it into usable Java objects and handle different number formats. It is very useful when working with dataset in a professional world way that follows good Java practice. Thank you for listening.
Hello, my name is Abdullah Hussein and my student ID is 383745. So I worked on the calculator. I worked on the calculator model in our carbon footprint application. The class I wrote is country emission country Java and is located in the service package. This class handles all the main calculation related to CO2 emissions. So the emissions factors. So the first class I defined three constants emission factors based on a real world data. This one, per liter of the kilowatt of electricity and per liter of petrol, also a kilogram of beef. These values are used to convert the user's monthly consumptions into carbon emissions. Then I have the main calculation method. The main method is called calculate user emission. This one. Uh, it takes in three inputs from the user: electricity in kilowatts, fuel in liters, meat in kilograms. Each value is multiplied by its um, emission factor and then by 12 to get the annual emission. We divide by 1000 here to convert it from kilogram into the metric tons. Then we do the same for the fuel and the meat here. Here how we did it in the double. Then we have to do the fuel and meat also the same way. Next, we do it the same way to give. Then we put it combine it together to get the annual fuel meat and annual electric and annual yeah, we combine it together so we get the total year footprint. Next we have the country. Find the country. Yeah, we give more methods to get the better result. First, you have find country. This method searches the data set for a specific country like Malaysia. Yeah. So the app can compare your footprint to a national average or another country or something like that. Yeah. Next, we add the highest emitter. This scans the list and returns the country with the highest CO2 here. Yeah. And next we do the list. We find the list of emitter. Then returns to the it gives the output for the lowest emitter. So here we get the highest output emitter output. Here we get the lower emitter output. Yeah. Next, here we got the public list country emission, get default data. Finally, I add a method that is called get a default data. This method returns returns the three hardcore country codes like Malaysia, China, and the US. It's helpful as a backup if the CSV file failed to load or we need to run a demo without real data. Yeah, I will continue in the next part. So this is my next part. I will talk about country emissions .java. It's part of the model package and it holds the data for each country. It stores four things. Okay, it stores the country and CO2 emission and the greenhouse gases GHG. Also, it stores the content. Next, there's also a getter methods like a get country and also get CO2, so we can use the values in other classes like here we get this and this also. Finally I added display method that prints the country's data in a clean format, so we call it. It shows the country name, CO2, GHG, and the contents nicely on the screen. It's a simple data class. It helps us display and organize country information, and that's all. Thank you for listening.
So, hi everyone, I'm Lo Wailun, and I'll be explaining about the emission data loader class, which is this one, which is located in a util package of our carbon footprint calculator project. So, this class is responsible for providing our application CO2 and greenhouse gas emission data per country. It serves as like a fallback data loader when our external file is missing or fails to load. So in the load data emission method, we manually populate a list of country, which you can see here, and you can actually add more country in it. And each object holds the country name, CO2 emission in million tons, total greenhouse gas emission, and its region. For example, the country Malaysia CO2 2277.53, greenhouse gas 306.7, and China shows like a high value in a global disparity in emissions. So later for the output, it will shows the comparison of each country. The second method is the load emissions, currently called the load default emissions, but can later be modified to a load from a file or database source. This class is important to our system because it ensures that we can always have base data available for comparisons, even if the external data fails to load. So this data we took it from Kaggle. Yeah. And in conclusion, our carbon footprint calculator successfully bridges the gap between complex climate data and everyday users by providing a simple console-based tool to quantify personal emissions. So let's look what we have achieved in our app. So we have a clear data integration, We source verified emission factors from Kaggle and EPA stored in emission factors.txt and loaded in dynamically to ensure accurate calculations. So we also build this application user-friendly. It's a user-friendly design. The app prompts user for just three inputs: electricity, fuels, and meat consumption, and transparently converts this into CO2 metrics using our calculator module. So there's some actionable insights. My analysis module transforms raw numbers into meaningful comparisons. For example, showing users how they are 14.4 annual tons stacked up against Malaysia average of 44.2 tons to a 3.4x difference. So we create this application to show some educational impact also by highlighting extreme like the highest or the lowest emitting countries. We contextualize individuals' action within global climate efforts, aligning with SDG 13 goals for awareness and empowerment. So we like to invite everyone to try our calculator, reflect on their footprint, and explore the ways to reduce it.